What we're going to start with today is there's these two families, very cleverly named Family A and Family B. And your job is to write at least two equations. You're going to try to write as many as possible, but at least two equations for each family situation. We've practiced this a lot. There's a situation or context. We write an equation that matches it, right? We had figs and almonds. We had lots of stuff. That's the one I remember for some reason. Protein and fat. Lots of things. We had a tank and we were losing water. Lots of things we've written equations for. So at least two different equations for each, but try to make as many equations as you can in the next 2 or 3 minutes. For Family A, I'm interested in hearing somebody's equation out there. What's one of the equations for Family A? Liam.
I said 18y minus 7 equals 11y.
18y minus 7 equals what?
11y.
If I did this, it'd be true.
Yeah.
But a similar one I think we can go with is 18 minus 7 equals 11. Another one I heard out there is 18 minus 7 equals, I'm just going to say A for Family A. Okay? What's another one out there that we got? Another equation. Yeah, Ellen.
7 plus y equals 18.
I'm going to just stick with the A because I have A, but 7 plus A equals 18. Yep, I got that one as well. Any other ones we got out there? I've got all we need actually to do what I want to do. So where I'm going to draw your attention is these two. Are they? So you're saying that they're both equations from the situation. So in theory, these equations, are they the same or different? Okay, so we have to be able to prove they're the same. Is there one way we can get one of them to be the other then? Is there one way we can get one of these to become the other? So what? Flip the 18. I think I need some more than just flip the 18.
Yes. Yeah. Switch the A and the 18 and the Y.
Yeah, but that would be, if I switch A and the 18, let's do that. A minus 7 equals 18. Okay, that's a good, I like it though. We can work with that. So what's on the same side as A on the bottom? No, the equal sign's splitting the two sides.
7.
The 7. Where's the 7 and the one above?
On the left.
Middle.
On the other side. So how do I get it on the other side maybe?
Flip it.
7a.
Here's what I'm seeing. I'm seeing add 7 to both sides. Let's check it out. If I add 7 to both sides, I get 18 equals A plus 7. These are the same. Okay? Let's look at B. Well, just know that I added the same thing to both sides, and now my equations are the same. That's the big idea on that, okay? B, what's an equation we got for B? Yeah, Greta.
U equals
11 minus 5. The middle child is 5 years older than the youngest. Well, I don't know where 11 came from. This is a whole new family, right?
11 came from like
Family A?
the child is...
Yeah, but these are two different families, Family A, Family B.
Oh.
So 5 years older than the youngest, I'm going to say youngest plus 5. How do you feel about that?
That feels...
I'm going to actually change B to M. It's going to help me. Middle. Okay, what's another equation we could have for this situation? If Y is 5 years older, M is what? 5 years younger, so... Does that make sense? Okay, and I got another one for you. The difference of their ages is 5 years. Would you agree with all those statements? So, since all these statements are this family B, what must be true about all three of these equations? They've got to be the same, so what we need to figure out is how do we get them to be the same to prove this? So, I want to focus our attention on the first two. How do I get one of these to become the other?
We do the same thing what you did before.
You add 5 to y.
Add 5.
Add 5 to this one?
Yeah.
So here's y plus 5. Here's y plus 5. Here's m. Here's m. They are the same equation. Excellent. Okay, now I want to focus on how do I go from, not that one, from one of these to the other. How can I go from one of those to the other? Add y to 5? What happens if I said take y away from y plus 5? So you're not wrong, Ray. I'm just showing you there's another way. M minus y equals 5.
Oh.
Ray was saying add y. So here's m, and here's y plus 5. Here's what you need to take away from this right now. The equations are all the same, right? I can get from one version to another by doing the same thing to both sides. So if I do the same things to both sides and get a new equation, my new equation is the same. Big ideas. What we're going to do, Tyler, I'm going to write this up here again. Remember we said the difference in ages was 5 years? Tyler is saying 2m minus 2y, or 2 times the middle's age minus 2 times the youngster's age is 10 years. I need you to decide if he is right and wrong and why. All right. Who votes yes? Same thing. Who votes no? Different. Interesting. So what did I say we could do? If we could do the same thing to both sides and get a new answer, we said it's the same, right? Okay, check this out. If I multiply everything up here by 2, I get 2m minus 2y equals 10.
That's what I would do.
Yeah, fine.
So, if we do the same thing to both sides and get it something new, is this something new actually new?
No.
It's the same thing, it just looks different.
It's the same thing but bigger.
It's not bigger, it's the same thing. It's the same equation. So, again, big idea. If I do the same thing to both sides to get a new equation, my equations are equivalent. So this is new. What we're going to do is practice. I'm going to let you know. You're going to look for equivalent equations on number 3 here. And in order to look for equivalent ones, what should we be trying to do? Something that we do to both sides to get another version, okay? So try that out with your partner. Look for something you can do to both sides to one of them to make it another one. Who's got a match and how do you know? And I like to just call these like one. It'll be easier for talking 1, 2, 3, and 4. How can we get from one to another one? Any ones you want to do? Ben, which ones are you looking at?
1 and 2.
One, okay, so how do you get from 1 to 2? What's something you could do to both sides of one of them?
Wait.
No, we're good.
I was thinking, no. I was thinking.
Okay, Lynn,
Could do like minus 6.
let's try it. If I do it to both sides, I get 3a equals 9. So say it. That's why I was like, hey, man, say it. So what must be true about these two? I did the same thing to both sides. They're the same. They must be equivalent. I also want to show you we could have done this. Oops. We could have done this. We could have added 6 to both sides. What's 9 plus 6?
15.
15. Thanks, us. All right, look for another one. What's something we can do to both sides? Ray.
1 and 3, and you times everything on 3, you times everything by 3.
Let's try that. 3a plus 6 equals 15. Awesome. Or we could have divided everything on number 1 by 3 and gotten to, divided everything here by 3 and gotten to 3 as well, right? Whoops. Okay, what about number 4? Can we get something to be number 4? Number 4. I got you. I see you, Ray, but I'm trying to get someone else going too. Elizabeth, is there a way we can get from 4 to... I'm going to give you advice. We're going to go 4 to number 2.
1/3 of 9 is 3, and then a. So we would take away
How about this? How could I get from here to here?
adding
Divide.
Not adding.
Times.
Time. So let's see. If we multiply this by 9, we get 3a equals 9. Winner, winner, chicken dinner. So these are all the same, y'all. If you solve for A, they're all A equals 3. And we can get from one to another by doing the same thing to both sides. So the big idea, I know I keep saying this, we have equivalent equations if we can do the same thing to both sides and get that new equation, all right? That's why you guys have solved equations before. That's why when you solve equations, it works, doing the same thing to both sides. Now we need to talk about pants. Okay. Noah's buying pants, and Noah's fancy. His pants, after taxes and a discount, cost $56.70. I'm more of a $5 pants from Goodwill kind of guy. $56.70 seems expensive. Back to these pants. Here is the equation for the situation. It was already given to you. There's pants, the 10% off coupe, there's tax, and there's a total. It's your job right now, just real quick, to say what the solution to this equation means. And you need to prove that 70 is not an answer and that 60 is an answer. So, James, what does X stand for?
The original price of the jeans.
Oh, dude, the OG price, okay? The jeans cost this much, I'm taking 10% off and so on. So if I put 70 in there, 10% of 70 is 7, right? So 10% off leaves me with $63 plus $270 to equal $65.70. So that does not work. That's the whole point of that, right? 70 does not work. Let's try 60. I throw 60 in there. 10% of 60 is 6. So $6 off. It's 54. You can do this in your calculator, right? 54 plus 270 equals 56.70. So what does that mean? What's the price of the pants? $60 pants.
How'd you get $6 off?
Yeah, I'm
10% of 60 is 6. It's 10% off.
Oh, so you didn't do like...
I mean, you can do this in your calculator. It gives you the same answer. I just was like,
No, it doesn't. When I put it in my calculator,
if you
I got 62.6.
if you put it in your calculator, you need to type this.
Or you could do,
Oh, alright.
Believe me, it works. Because the pants are 60. It's the price after the discount. So this looks wordier than it really is, so stay with me. We're still on the pants. What they're going to do is, in the situation, they're going to mess with our original equation. Remember, if we mess with our original equation and we do the same thing to both sides, our new equation is equivalent. So, all three of these situations, there's 3 parts. What was done to it? What does that mean in context? And does it change the answer? And you're going to be given one of those. So, for example, let's do this first one together. The price is expressed in cents instead of dollars. So someone just wants to sound real cool. Be like, how much are your new pants? Be like, 5,670 cents. They're like, what? Yeah, 5,670 cents. They're thinking you got some fancy jeans, okay? Anyway, right now, who can tell me, what did they do to both sides of the equation? What was done to it? Hey, I'm on the right track. How many cents in a dollar, friends? Yeah. So they multiplied. Oops. I'm on the wrong thing here. They multiplied by 100. Everything, right? Both sides. Both sides. What do we know about if we do the same thing to both sides? It's equal. So guess what happened to the answer? Same answer. If you do the same thing to both sides, we get the same answer. I can prove it to you if you want. Let's do that. Whoa, I'm not on the right slide. You guys didn't tell me. I really jacked that up. Here we go. There we go. So what was done? Multiply both sides by 100. And then, yes, same solution. So if you want to solve it real quick, I'll solve this one. You'll just trust me on the rest. 1,670. So I got that 90x by doing 100x minus 10x. I want to subtract 270 from both sides. That means 90x equals 5,400, which means x equals 60. Are the pants still $60? I did the same thing to both sides. I still got $60 pants. All right? Next up, B. Let's look at that. They're saying what's done. Subtract 270 from both sides. What does that mean in context if we're getting rid of 270?
No, subtract 270.
Yeah. Remove the tax. If we do the same thing to both sides, what's going to be true about our answer? Our answer is the same. Still $60 pants. C. Right here. They added my 1x and my negative 0.1x to get 0.9. Right? They combine these like terms right here to get 0.9x. Do you think that changes my answer? No. You'd have to do that to solve for x, right? It's just combining like terms. Did we do anything to either side? We actually didn't do anything. Okay. Now, before we move to the next slide, the big idea is if we do it to one side and we do it to the other, we get equal equations, equivalent equations. Okay, I know I've said it a million times, samesies. So check these ones out. On these ones here, they take the price after using the coupon 10% off and before sales tax, and it's still $56.70. If they take the tax off and the total still $56.70, can the original price of the pants be the same? No, not the same. How about this one? They're taking $270 from the left and they're just adding it to the right. So now, no tax and the total's more. Can we have the same answer? No. They didn't do the same thing to both sides. Down here, they're doubling what's happening with the 10% off and the tax, and our answer does not double. Could we possibly get the same x? No. Big idea. If we don't do the same thing to both sides, we only do something to one side, do we have an equivalent equation? No. To get the equivalent equation, we have to mess with both sides. Same thing to both sides. I feel like I said that a couple times today. That's because we can tell if expressions are equivalent or not if we can get to a new expression by doing the same thing to both sides. So we have to practice identifying those moves, and we understand equivalent means the same. That's it.